It is February and it is 76 degrees out today. So I am filming outside, but I live right by an airport, so fingers crossed it won't be too loud. Cole, do you want to help me with a geology video? He does not want to help me with a geology video. That's okay, because I have a little manatee friend here. Manatees. They're like pugs. Kinda ugly, but also irresistibly cute. Back in November, I got to see them in the wild for the very first time. Dozens and dozens of them. I lost count. From November to March, you don't have to travel out to the ocean to see them. You can find them pretty far inland from the Carolinas to Louisiana and sometimes beyond, though it's rare. The majority of them stay in Florida, feeding on seagrass and swimming away from stalking snorkelers. If you've been living under a rock, like I often do, literally, you may not have heard about this insane winter storm that ripped through much of the southern U.S., dumping 13 inches in Louisiana and close to 10 in parts of Florida. And of course, my mind went to the manatees. I wondered, how were they doing with all of this snow? Why am I talking about manatees when I'm a rockologist? Well, little did you know is that manatees actually depend on Florida's geology. That's right, I said it. If it wasn't for Florida's geology, manatees would not exist there. In today's episode, we will learn about Florida's geology, specifically what an aquifer is and how it's related to protecting manatees. We will also explore how the recent winter storm that closed major highways in the south is affecting manatees and if the geology is enough to save them. The entire state of Florida is underlaid by limestone, which was deposited when this region was underwater. Thanks to the very rainy conditions of Florida and the weakly acidic nature of that rainwater, the limestone is easily eroded as rainwater flows over the land and into it. This gives rise to what is known as karst terrain, which can look a lot like Swiss cheese. This is why Florida has so many sinkholes, springs, and caves, and why I would not want to live there, among other reasons. Why would a manatee care about karst? Well, first, we'll have to understand what an aquifer is. You may have heard of it. A lot of people think of an aquifer as a large natural container of water under the ground, which is not completely true. An aquifer is a body of rock and sediment that is saturated with water. Water is in it, around it, and moving through it. This water is known as groundwater. These aquifers can be confined or unconfined. Confined aquifers occur where there is an impermeable layer below and above the saturated zone, not allowing water to rise or fall much, unless there are outside forces. These aquifers are under pressure, so when an outside force known as a geologist drills into them, water will often flow into the borehole and sometimes to the surface without the need of a pump. Unconfined aquifers have no impermeable layer between it and the atmosphere. This means the water can rise and fall due to varying environmental conditions. Aquifers are recharged or refilled as rainwater percolates into the soil. For unconfined aquifers, this is a simple process, but for confined aquifers, it's a bit more complicated since water can't get through confining layers. Either water will infiltrate into fractures in the confining layer or where the impermeable layer is absent. The process for water to reach a given aquifer can take a few years to centuries, and some of that water will never reach the aquifer at all. It depends on a number of factors, including lithology, which is rock type, presence of voids or fractures, and proximity of the aquifer to the surface. The USGS has identified 68 total principal aquifers across the U.S., which are regionally extensive and can be used as drinking water sources. In Florida, the largest aquifer is known as Do you want to guess? That's right, the Ohio aquifer. What? You don't believe me? You're right. It's actually known as the Floridan aquifer system. The Floridan aquifer system is under the entire state of Florida and then some. And by some, I mean areas of Bama, Georgia, and South Carolina. The groundwater system in Florida contains multiple aquifers: the superficial aquifer, the intermediate aquifer, and the Floridan aquifer. The superficial aquifer, aptly named, is the uppermost unconfined aquifer. At the base of this aquifer is a layer of impermeable clay. There are sections of this clay layer that is discontinuous, meaning water from the underlying aquifers are in direct contact. Below the superficial aquifer is the intermediate aquifer. Yeah, hydrologists can be kind of lame with their naming if you haven't noticed. This is a confined aquifer just above the Floridan aquifer. It's not a simple layered cake scenario. It's more like you stumbled upon some cake in the break room and you couldn't resist, taking a bite and maybe another, and then you realize your mistake and try to rearrange some things. So it looks like you didn't eat 1/4 of the cake, but it just doesn't look right. Beneath the surface, you have confining rock layers thinning in places or not even there, so aquifers are a bit of a jumbled mess. And to make things even more complicated, the Floridan aquifer is further divided into the upper and lower Floridan aquifers. So you might be like, Geology Joes, get on with it. What about the manatees? Patience, I'm getting to it. So we've learned how these aquifers are recharged, but how is water discharged from the aquifer without interference from a geologist? Discharge occurs in low-lying coastal areas and in surface water bodies like wetlands, lakes, rivers, and springs. In Florida, the origin of the discharged water varies from one body of water to the next, and with it, water quality. In the case of Cypress Springs in the panhandle of Florida, the water bubbling up to the surface comes from the Floridan aquifer, which, as you can recall, is the deepest and most extensive aquifer in the groundwater system. Wild. And look at the water coming out of the underground cavern. You can see it right there. Wow, it is so blue! Oh wow! This is, wow, so pretty. This might sound pretty confusing because why would the water come from the deepest aquifer and not the more shallow aquifer? Well, I'll show you. In this diagram, you can see all three aquifers. You can also see the impermeable clay layers and where they stop, creating our jumbled layered cake. You may also notice that where the other aquifers end, the Floridan aquifer sits close to the surface with only sand above it, which is very permeable. You can also see where caves and cracks have formed in the limestone layer, allowing water to very quickly fill the voids and flow out of the aquifer, or in. Depending on the location and hydrologic conditions, rivers and streams can serve both as recharge and discharge points. When water levels in a lake or stream are higher than the surrounding groundwater, the surface water body may provide recharge to the aquifer. For example, when a river floods, it can actually reverse flow, bringing water into the aquifer. Conversely, the aquifer may discharge water into surface water bodies if levels are higher in the aquifer due to pressure. Aquifers play an integral role in surface water body conditions, including spring flow or stream flow, water levels, saltwater intrusion, and biological health because of this give and take relationship. This is the reason why it's so important to manatees. Manatees are not about the cold. So in winter, when ocean temperatures dip below 68 degrees Fahrenheit, they go inland to the springs. If they don't, they will die. Manatees use the karst terrain, specifically the underwater caves and corridors, to find warm water. Thanks to the aquifers, which are shielded from major temperature fluctuations because the surrounding rocks and sediment act as a natural insulator, the springs stay around 72 degrees year-round. But is it enough to shield them from historic winter storms? This past week, Florida and much of the southern U.S. was pounded with snow, closing many interstate highways, including I-10 through the panhandle of Florida. Some places in Louisiana saw more than 13 inches of snow, unlike anything the area has seen in 130 years. Cities in the western panhandle of Florida saw between 5 to 10 inches of snow. The official total from the National Weather Service was 7.6 inches in Pensacola and 9.8 inches in Milton, Florida. Florida has seen snow about 80 times since 1886. That's 80 times in 138 years. The last time snow was recorded was 10 years ago with a measly 1 inch in Pensacola. So the question is, how does this record snowfall and frigid temperatures affect the manatees? Well, from what we can tell, it affects them very little, other than more manatees migrating to power plant discharge areas and becoming more sluggish to conserve energy. In Florida, below freezing temperatures have minimal impact on natural springs because the aquifers do a good job maintaining a relatively constant temperature, well above freezing even with a historic storm. However, prolonged unseasonably cold weather may have an effect, though we have yet to see this due to its rarity. While the warm water of the springs is generally enough to keep the manatees from going into hypothermia, there is another problem that the manatees face that the geology cannot help with. Due to nutrient pollution, harmful fishing practices, and the effects of climate change such as rising sea levels and worsening storms, seagrass in Florida is suffering. Seagrass is a staple of the manatees' diet, and unfortunately many springs and estuaries that once hosted seagrass no longer do, so manatees have to venture farther into cold waters to feed, risking hypothermia. Manatees are known as sentinel species. That means they are indicators of how the environment is doing and the first to show effects when there is dysfunction in the ecosystem. For years, manatee populations have been plummeting due to starvation and have experienced large die-offs, leading people to temporarily feed them lettuce while trying to resolve the food shortage issue. This issue not only affects the manatees but other animals as well. Seagrass is not only a vital food source for sea turtles and fish, but are used as shelter and nursery grounds. It is the base of the food web, and if it is removed, the entire metaphorical pyramid will collapse. Unfortunately, the geology is not enough to save the manatees and other creatures in this circumstance, but humans are. Humans created this problem, and it is possible for us to fix it. It's important to call and write our politicians and demand better water quality standards and environmental protection measures that not only benefit the ecosystem but humans as well. You remember those aquifers we learned about? In Florida, 90% of the drinking water comes from aquifers. The same contamination, such as fertilizer, pesticides, and animal and human waste that affects seagrass and manatees, can end up in aquifers, especially in high recharge areas. The upper Floridan aquifer and surficial aquifer are especially vulnerable to contamination. Additionally, increased rates of water withdrawal from aquifers can speed up the migration of contaminants and increase the likelihood of saline intrusion, which is when ocean water gets into the aquifer. But it's not only in Florida that aquifers are seeing contamination and other concerning issues which affect public health and drinking water. But that's a topic for another video. Well, that's all I have for you today. I hope you enjoyed learning about the manatees and one of my favorite topics, aquifers. In the future, I want to talk more about environmental contamination and how it affects us. If you think that's interesting, leave a comment down below telling me. And if it doesn't sound interesting, you can also leave a comment down below telling me what you would like to see. This has been Geology in the Face, and I hope to see your face next time. Bye!